Good morning. So what we're going to be doing today is we are going to be talking more about inverses, but in a different way. So before we talked about inverses, we talked about exponents. Well, the inverse of an exponent is something called a logarithm. All right, this is dying. I'm going to use a new marker. So, what is a logarithm? Well, a logarithm, or what I like to just say log because it's easier to say and I'm lazy. So a logarithm, what it does is it answers the question, what exponent do we need to raise the base to get the product? So when we were just looking at our power puzzles, we were looking at that little, what do we need to do? What to the what gives me what? That's a logarithm. So instead of the word power, you could have put in the word log, and you discovered what a logarithm was, which is the inverse. Remember, it undoes an exponential equation. So we kind of showed what the power was for that puzzle. But in terms of logs, it would look, this is the general form of a logarithm, is log base b of y equals x. So just like, remember, the general form of our exponential is b to the x equals y. So these are the things we're going to be looking at. So for our logarithm, the b is our base. And I like to think base is on the bottom because it's a small number on the bottom. Our y is our product or our answer. And then our x is our exponent. So that's what I like to think about because that will help me change the form. So we're going to start first by changing exponential to log form because we're used to exponentials the most. So our exponential function is b to the x equals y. The way we take the inverse is we need to change the base. So I'm going to take this base and I'm going to move it to the other side of my equal sign. So what's left on this side? I have an x left, and it's going to equal something. Well, the inverse of our exponent is a log, so it's going to equal log. Now, what I like to think to myself to help me write it is I want to think log base b. So whatever my base is, my log, I'm going to have a tiny b, base b, and then whatever we're bringing it here stays the same, so y. So the biggest part is we're just moving the base from one side of the other, and we're writing log because that's the inverse. So let's do a couple examples. So, for example 1. So say I have 4 to the third power equals 64. So I'm going to look for my base, which is 4, and I'm going to move it to the other side. Then I'm going to think to myself, all right, I'm going to have log base 4. And that's going to help me with rewriting. Because I look over here, I move the base So I have the 3 left on this side. It's going to equal log base 4 to the 64. And we've rewritten that one. Let's try another one. So for our second example, let's say we have, and we're going to learn how to solve something like this tomorrow. So get excited. So let's say we have 6 to the x equals 53. We don't know what this x is, but that's totally fine because we still do the same process. So I'm going to circle my base and I'm going to move it to the other side. So I like to say to myself again, I'll have log base 6 because 6 is my base. You don't have to put this if you don't want. I just like to put it because it helps me remember what I'm doing. So what's left on this side is my x, and it's going to equal log base 6 of 53. And this is my answer. Tomorrow, we're going to take it a step further, and you'll actually be able to tell me what x is. So get excited for that. So that's exponential to log. Well, you can also go the other way around. So we're going to look at from log to exponential. And I am lazy, so I just wrote log to exp. You got this. So I'm going to do it in general first, and then we're going to do a couple practice problems. So in general, I have log base b of y equals x. That's our general form. Well, we start with the same sort of thing. We identify our base. So our base is at our bottom, or our little number. So I have base b, and we're going to move it to the other side. When we were changing exponential to log, we had to add the log. When we're changing log to exponential, we drop the log. So the log falls off. And what we're left with, I have the y left on this side equals my b stays the base. So it stays on the bottom, and the x or whatever what it was equal to moves to our exponent. So we're still moving that base and we're changing it into an exponential function. So let's do an example. So for example, let's say we have log base 5 of 1. Notice how this isn't equal to anything. Well, we have to make it equal to something then. So I'm going to write log base 5 of 1 equals x, because we don't know what it is, so I'm just going to assume it's an x. So first, I identify my base. That's my small number on the bottom, and I move it to the other side. Next, because I'm taking the inverse, my log is going to drop off. It's going to disappear. So all I have left on this side is I have 1, and it's going to equal, my base is going to stay on my bottom, and whatever's over here is going to become my exponent. So let's look at another one. Let's look at, say we have log base 2 of 8. So again, this one's not equal to anything, so I have to set it equal to something. So I have log base 2 of 8 equals x. So first steps first, look for my base, which is 2, move it to the other side. Then we are taking the inverse, so we drop our log, it disappears because we're turning it into exponential. So what's left on this side is 8, and it's going to equal my base, which is 2, raised to the x. So there's one more caveat I need to let you know about for logs. So our last example, which I might run out of room, we'll see. Our last example, say we just have log 2. This doesn't have a base. So you're probably like, but miss, what do I move to the other side? Do I just put do I put an X? No. For this, what is good to know is a log without a base is log base 10. So if a base, just like if we have an X, it's assumed to have the 1 in front. For logs, it's assumed to have a 10 as its base. So for this is actually the same thing as log base 10 of 2. And then it would equal X. Then we would do the same thing. We would circle our base and we would move it. So my base here is my 10. I'm going to move it. We're changing it to the next thing. So our log is going to fall. And we're going to end up with 2 equals 10 to the X. So that's how you change it with writing. But we are in this virtual world. So you don't have to write this down. I just want to show you this is how we're going to do it when we're doing our Desmos. So this is going to be a little different than what we're used to. So we're going to go back to when we were doing exponential to log form. So to help us show what we're doing, I'm going to use this sketch pad. And I'm going to circle. Ooh, that's terrible. If you ever do something like that, you can always erase it. So I'm going to sketch. I'm going to circle my base. And I'm going to draw my arrow. So I'm going to do the same sort of thing we were doing in our notes. And now I'm going to write my answer here. The thing about writing logs is it's a little bit tricky. So I know I have my X equals. And I know I have my log, but then you're like, miss, how the heck do I write that little number? What you want to do is you want to do the underscore. So if you see like where you usually do with the minus sign, you want to press shift and your minus sign and see how it moves my little arrow down. That's how it writes on the bottom. And that's where I want to write my 6. So again, to get that little one, you press shift and then the minus sign. So your underscore is going to give you the little thing. My base is 6. And then I'm like, okay, my next thing is 53. But everything's still under. So to make it go back up, you want to press the right arrow. And then see how my cursor is back up, and that's when I want to write my 53. And this is nifty. It gives us our answer, but we're going to learn how to do these tomorrow so we know exactly what they're doing. So that's how you write logs. We're going to go to our next one in what to do to write our exponents. So this is just like our problem for example 3. So we set it equal to 0, back to X, sorry. We circled our base, we moved our base, we dropped our log. So then up here with our answer, we have only the 1 left. Then it equals, our base was 5. And just a reminder to get to your exponent, it's shift 6. And see how it moved my cursor up? And that's where I want to put my X. So that's just how you want to put those in the screen for Desmos. I'm going to teach you kind of how to put it in the screen when we're not working on Desmos, when we don't have like a fancy calculator built in at a later date. But I hope that was helpful. On the next slide of your make sure you are uploading these notes, and on the next slide of your Desmos activity, you're writing whatever questions you have. So I will see you soon.